Hello everybody, my name is Bernt Mikal Larsen. I work for Multiconsult in Norway, and today I want to share a case study with you about shore power. The presentation is called Shore Power Connection for Offshore Vessels, Measured Noise Reduction in Port and Dock. First, a little bit about the method. We had two places in Kristiansand where we measured effect of shore power. One place is called Kongsgård, probably future harbor. Another place, Andøya Industripark. We did continuous registration of noise at the building close to the port dock. And we also had to do some considerations. We compared the noise levels with and without shore power when one ship was in port or dock, and we used the level of nights for comparison to avoid the influence of other background noise. And we also had to eliminate nights with heavy rain or wind when analyzing the data. Rain and wind will, of course, give a high noise level, so that's why. The measurements at both locations were with one microphone position at the port building for long time registration. It's important to have emission point with low influence of background noise. And also a microphone in height, not shielded. So the focus was on one good microphone position with low background noise. And with omnidirectional radiation, like we think there is from a vessel, this is thought to be good enough. So a very important focus on a good measurement point. In this case, we compared measurements and calculations. Noise maps were calculated with the program Cadna for both places, and the level differences at port building was used for estimating LW with shore power. The Cadna model shows calculated level at port building corresponds with measured level. The point source model with omnidirectional sound radiation gives same noise level as measured on port building, and also shows very good correspondence with short time measurements in other direction in the port area. Here the location Kongsgård, where we did measurements of drilling and pipelay vessel. Here is from the calculation model. You can see the situation with the location of the vessel and emission point at port building. What did we get by the measurements at Kongsgård? For drilling vessel, LW 110 dB without shore power connection, and LW reduced to 92 dB with shore power connection. For pipelay vessel, LW 105 dB without shore power connection, and reduced to LW 90 dB with shore power connection. There is also some important and interesting things about the frequency spectrum. For the pipelay vessel, we present two cases here. So you see the level without shore power and the level with shore power connection. There is quite good reduction and good effect. And it's interesting with the low frequency noise, which often gives annoyance for the neighborhood. But this is a measurement September 2021, and we also had another measurement January 2022, showing the level, the frequency spectrum without shore power and with shore power. This is also explained in the paper. What can we say about comparison of these two measurements? The noise reduction due to shore power is good in all frequencies or octave bands. The noise level with shore power connection is quite similar in all octave bands for the two periods. I underline the noise level. We can kind of see the noise level is brought down to something similar. In both cases, the noise level is reduced to a similar level, which is dominated by ventilation fans or other noise sources on the vessel. Shore power only affects the auxiliary engine, so that's why this is important. For the pipelay vessel, there was also some difference between measurements. The reason for the different level without shore power in September 2021 and January 2022 is not exactly known. We know that there has been some tests sometimes at this vessel. The noise data summarized for shore power in the table for September last year is based on the nights with lowest level. Other nights with higher noise levels may have been with unknown noise sources active. And the other location I mentioned is Andøya Industripark. There we have measurements for offshore support vessel. So we did measurements of two offshore support vessels at Andøya Industripark. Here you see a sketch where the vessel was located in dock here, an emission point on a office building or port building. A good emission point without significant influence from background noise. What did we see with the offshore support vessels? The results from Multiconsult's measurement, LW100 and LW107dB without shore power for two different vessels, and LW brought down to 94 dB with shore power. The difference in sound power level without shore power for the two different offshore support vessels, as you can see given above, is mainly explained by different design of these two vessels. So the most noisy had the cheapest design. Summary of the measurement. We did measurement on the building, office building with continuously registration. And there were two vessels, MMA Pinnacle in December 2021. Here you can see the noise levels for different nights. And we also had another vessel in January this year called Norman Jarstein, and there you can also see the different levels. And Norman Jarstein was connected to shore power. If we analyze the measured levels from the two vessels, we see the following. Some nights when the first vessel, MMA Pinnacle, was in dock were without the harbor generators running, which is reason for lower noise level. We got confirmation about this. Both vessels give noise level of 49 to 50 dBA on the office building when harbor generators are off or the vessel is connected to shore power. The noise level of 48 to 50 dBA on the office building is assumed to be dominated by fans and ventilation on the vessels. This is a quite constant level, so therefore we don't believe it comes from something else. It comes from a kind of constant source like fans and ventilation. The low noise level for the vessel MA Pinnacle, one period, 42 to 43 dBA, may be explained by that either fans or ventilations were turned off such periods. Here we see frequency spectrum for the offshore vessel called Norman Jarstein. which was connected to shore power. So you see the level without shore power and with shore power. And comment about this table, the noise level in the upper frequencies or upper octave bands are quite similar with and without shore power. So then they come from other sources than the auxiliary engine. It is highly probable that the noise level from 250 Hz and above is due to a constant source like ventilation or fans. The measurement for Norman Jarstein shows very good effect of shore power in the low frequencies. And then we come to conclusion for offshore vessels and shore power. Shore power connection for drilling and pipelay vessels brings the sound power level LW down from 105 to 110 dB to 90 to 92 dB, measured at Kongsgårdvika. Offshore support vessels have sound power level of 94 dB with shore power connection. In all cases, shore power connection gives significant reduction of low frequency noise. For drilling, pipelay, and offshore support vessel, the level is 50 to 60 dB at the office building in frequency range from 63 to 1000 Hz when connected to shore power. And the measured noise level with shore power is dominated by fans, ventilation, and other noise sources on the ships or vessels. So further on, maybe things could be done to also reduce levels by fans or ventilation to the surroundings. But as I mentioned, annoyance in neighborhood seems to be related to low frequency noise, and therefore to reduce this low frequency noise with shore power for auxiliary engine is a good thing. This is the concluding slide, but there is still one slide to go to maybe make it simple and maybe something you can remember. It's a poem. So it's like this. Shore power in port and dock. Low frequency noise will block. The neighbors will all sleep well and long, and next morning feel very fresh and strong. Thank you for being able to give this presentation. All the best.